Okay, so today we're going to be starting on page 117, and it's going to be coordinate geometry, proofs, day 2. So our objective today is to prove shapes using coordinate geometry. So we're going to start with our first example, and it's going to be prove the quadrilateral with points A, 1, 2, B, 2, 5, C, 5, 7, and D, 4, 4. So we want to prove this quadrilateral is a parallelogram. So in order to do this, we need to prove that our quadrilateral has 2 sets of parallel sides. So parallel sides, we're going to show that we have equal slopes. So we're going to be using our slope formula. So slope is equal to y2 minus y1 over x2 minus x1. That's what we're going to be using. So we want to prove, well, first we want to graph our shape. So we're at 1, 2, 2, 5, 5, 7, and 4, 4. So we want to find our slope of line AB. So we have 5 minus 2 over 2 minus 1, and that gives us 3 over 1, or just 3. So this was our slope of AB. Now we want to find our slope of line CD, which is this line here. So we have 4 minus 7 over 4 minus 5. And this gives us 3 over 1, which is 3. So we still need to prove that 2 sets of parallel sides. So we have that AB and CD are parallel because they have the same slopes. So now we want to prove that BC and AD are parallel. So we need to find the slopes of both of those lines. So we have slope of BC would be 7 minus 5 over 5 minus 2. This gives us 2 over 3. So now we need to find our slope of line AD. So we have 2 minus 4 over 1 minus 4, which gives us a negative 2 over negative 3, which is 2 over 3. So we see that BC and AD have the same slope, so this means that they're also parallel. So we proved that AB is parallel to CD and BC is parallel to AD. So we write AB parallel to CD and BC is parallel to AD. So we can conclude that quadrilateral ABCD is a parallelogram because it has two sets of parallel lines. So in our second example, we're going to be proving that a quadrilateral with points A, 1, negative 2, B, 13, 4, C, 4, 7, and D, negative 2, 4 is a trapezoid, but is not an isosceles trapezoid. So the first thing you want to do is to plot our points. So we have 1, negative 2, 13, 13, 4, 4, 7, and negative 2, 4. C and D. So we can connect our points to draw our shape. So for a trapezoid, we need to prove that one pair of sides is parallel. And the other pair is not parallel. So we can prove this by using our slope formula. So we can want to find that the slope of AB and DC are the same, because that would be parallel slopes. So we can find the slope of AB, which is 4 minus negative 2 over 13 minus 1. And we get 6 over 12, which is 1/2. So now we find the slope of DC. And that's going to be 7 minus 4 over 4 minus negative 2. And we get 3 over 6, which is also 1/2. So we see that our slope of AB and our slope of DC are both 1/2. So that means that they're parallel. Now we need to prove that the other side, the other pair, is not parallel. So we need to prove that DA and CB are not parallel. So we need to find the slope of these two. So the slope of AD is 4 minus negative 2 over negative 2 minus 1. And we get 6 over negative 3, or a negative 2. So now we need to find the slope of BC. And that's going to be 7 minus 4 over 4 minus 13, which is equal to 3 over 9, or 3 over negative 9, which is equal to negative 1/3. So we can see that these slopes are not the same. They're different. So we just proved that our opposite sides, our two other opposite sides, are not parallel. So DA is not parallel to CB. So we can write AB is parallel to DC, but BC is not parallel to AD. So we can say that ABCD is a trapezoid because it has only one set of parallel sides. So we just proved that this shape is a trapezoid, but our question is asking to prove it's a trapezoid, but that it's not an isosceles trapezoid. So to prove that it's not an isosceles trapezoid, not isosceles, we want to prove that the non-parallel sides are congruent. Are not congruent. So to do this, to see that if sides are congruent, we can use our distance formula. So our distance formula is square root of x1 minus x2 squared plus y1 minus y2 squared. So we can find the distance between line AD, and that's going to be 1 minus negative 2 squared plus negative 2 minus 4 squared, which gives us 3 squared plus negative 6 squared, which is square root of 9 plus 36, which is square root of 45. So the distance of AD is square root of 45. So now we want to find the distance of BC. So we're using distance formula again, and that's going to be 13 minus 4 squared plus 4 minus 7 squared. And this is 9 squared plus negative 3 squared, which is 81 plus 9, which is equal to square root of 90. So we have AD and BC. These are the non-parallel sides, and we just proved that they're not equal, so that means that they're not congruent. So we write AD does not equal BC. So therefore, ABCD is not an isosceles trapezoid. And that's because the legs are not equal. So now we're going to do one more example, and this is going to be example 3. So this example is to prove that quadrilateral ABCD with vertices A, negative 3, 2, B, negative 2, 6, C, 2, 7, and D, 1, 3. So we're proving if this is a rhombus. So to prove this, we have to prove all sides are congruent. So we're going to plot our points. So we're at negative 3, 2, negative 2, 6, 2, 7, and 1, 3. So we're connecting our shape here. So we said we have to prove that all sides are congruent. So we're going to be using our distance formula again. So we have x1 minus x2 squared plus y1 minus y2 squared. So if we find the length of, we can start with AB, line AB. So we have square root of -3 minus -2 squared plus 2 minus 6 squared. And this is going to give us square root of 1 squared plus -4 squared, which gives us 1 plus 16, which is square root of 17. So we have AB has a distance of square root of 17. So now we can find the distance between BC. So we're using the distance formula again, and we have -2 minus 2 squared plus 6 minus 7 squared. And this is going to give us -4 squared plus -1 squared. And this is 16 plus 1, which is square root of 17. So now we're finding the distance between CD. So we have 2 minus 1 squared plus 7 minus 3 squared, which is equal to 1 squared plus 4 squared, which is equal to 1 plus 16, which is also square root of 17. So now we have our last line, we have AD. So we have -3 minus 1 squared plus 2 minus 3 squared. This gives us -4 squared plus -1 squared, which is square root of 16 plus 1, which is square root of 17. So we can see that AB equals BC, which equals
Keasia
CD.
Harold, please come to the guidance office. Keasia Harold to the guidance office.
Which also equals AD. So this is making opposite sides congruent as well as all sides. So now we can say that ABCD is a parallelogram because its opposite sides are congruent. And now we can conclude and say that ABCD is a rhombus because it's a parallelogram with all sides congruent. So we just proved that this is a rhombus.